Hello students, welcome to today's science lesson on light and image formation. Have you ever wondered why you can see yourself in a mirror or how a lens in your spectacles or camera forms an image? In this lesson, we will explore how light behaves when it meets different surfaces like mirrors and lenses and how that helps us to see the world around us. Now let us see the different types of mirrors like plane mirror, concave mirror and convex mirror and its symbolic representation as shown in the figure. In the first figure you can see the symbolic representation of plane mirror, and in the second figure you can see the symbolic representation of concave mirror, and in the third figure you can see the symbolic representation of convex mirror. In the symbolic representation you can see the uh, lines which has been drawn. Those lines are the polished surfaces of a mirror. In our lower classes we have seen about reflection of light. What is reflection? What is reflection of light? Reflection of light is a phenomena where light rays bounce back after hitting a shiny surface. Because of reflection, we can see our own image in the mirror. There are two laws of reflection. The first law, the angle of incidence is equal to angle of reflection. In general, we say angle I equal to R. For example, if angle I is 60 degree, then angle R will also be 60 degree. So the problems can be asked, what is the angle of incidence if the angle of reflection is 60 degree? So if the angle of incidence is 60 degree, the angle of reflection is also 60 degree. Another example we can give, if angle of incidence equal to 30 degree, so angle of reflection will also be 30 degree. And the second law says that the incident ray, this is the incident ray, and we have a reflected ray and normal all lie in the same plane. So these are the two laws of reflection. The first law is angle of incidence is equal to angle of reflection. The second law states that the incident ray, the normal to the mirror at the point of incidence, and the reflected ray all lie in the same plane. Now let's begin the important concept of this lesson, image formation in plane mirror. The most common type of mirror we see at home is the plane mirror. When a light falls on a smooth, shiny surface, it bounces back. This is called reflection of light. In a plane mirror, the image size as object, but it is laterally inverted. What do you mean by laterally inverted? If we raise the right hand, we will see the left hand in the mirror. It will appear as if the left hand is being appeared in the mirror. So this concept is called laterally inverted. And also you can see here the object. Here you can see in the left hand side of the mirror, the incident ray falls on the mirror and you can see the image is formed behind the mirror. The image is formed. The object is H1 and image is H2. So we can call H1 equal to H2. So the height of the object is equal to height of the image. And also the distance between the mirror and the object is U is equal to the distance between the mirror and the image, that is V. So U is equal to V. So we can call object distance is equal to image distance. So we can conclude that the image formed by a plane mirror is always virtual and erect. It is going to be erect and virtual. The size of the image is equal to the object. So H1 equal to H2. The image formed is as far behind the mirror as the object is in front of it. So the object distance is equal to the image distance. Further, we can conclude that the image is laterally inverted. Next, let's move to spherical mirrors. These mirrors are not flat. They are curved surfaces taken from a sphere. There are two types of mirrors. One is concave mirror, another one is a convex mirror. A concave mirror which curve inward like a spoon, and convex mirror which bulge outward like in the back of the spoon. Each of these mirrors behaves differently and forms different kinds of images. To understand how mirrors form images, let us learn some important terms. Some basic definition of spherical mirrors for aperture, pole, principal focus, center of curvature, and radius of curvature. You can see in the picture for convex and concave mirror, the aperture for both convex and concave mirror. Aperture is the place where the light can pass through for refraction. And you can see the pole, capital letter P, is the midpoint of the mirror that serves as a geometric center. So P can be located in both convex and concave mirror. Then if you see capital letter F, principal focus. The principal focus is a point at which parallel rays of light either converge or appear to diverge after reflecting from a mirror or reflecting through a lens. Then we can see center of curvature. The center of curvature is the center of the sphere of which the mirror surface forms a part. It is located directly behind the mirror and is twice of the focal length. If you draw a circle, we have a center of a circle. Similarly, in a spherical mirror, center of curvature is like a center of the spherical mirror. And you can see radius of curvature, small letter r. The distance between the center of curvature, capital letter C, and the pole P is called the radius of curvature. Principal axis is an imaginary line passing through center of curvature C, principal focus F, and pole of the mirror. If a line joining center of curvature, principal focus, and pole of the mirror, then it is called principal axis. What is focal length? The distance between the pole and the principal focus. So the pole and the principal focus is called focal length, which is represented in small letter F. So these terms, what we have studied, help us to draw accurate ray diagrams and locate where images are formed. Now let us learn some basics to draw ray diagrams for concave and convex mirror. Now let us learn how to draw the ray diagram for a concave mirror. Draw a concave mirror showing the reflecting and non-reflecting surface and draw a straight line intersecting the concave mirror, and the intersection point we call it as capital letter P, which is called the pole of the mirror. Take 1 or 2 centimeter from pole and mark that point as capital letter F, which is called the principal focus, capital letter F, and mark another point which is equidistant from PF and mark that point as capital letter C, which is called the center of curvature. Now we know that we have already studied a line joining the pole of the mirror, principal focus F, and center of curvature is called principal axis. Now let us learn for convex mirror, how to draw the ray diagram for a convex mirror. First, draw the convex mirror showing the reflecting and non-reflecting surface for a convex mirror. Then, as usual, draw a principal axis, a line, straight line, and the intersecting point of the mirror and the straight line is called the pole of the mirror. Then mark in the reflecting surface side a point and it mark it as the focus, principal focus F. And equidistance, take equidistance and mark that point as capital letter C, which is called the center of curvature. So the line joining center of curvature, principal focus, and pole of the mirror is called the principal axis. So we have learned how to draw for concave and convex mirror. The template for before drawing the ray diagram, we should know how to draw these basic templates for the ray diagram. Apart from the basic concepts of learning how to draw the ray diagram, we should also know what are the rules for image formation by a spherical mirror for concave and convex mirror. Rule 1. You see the diagram first of all for a concave mirror in the left hand side and convex mirror on the right hand side. This is a concave mirror. This is convex mirror. For concave mirror, a ray of light parallel to principal axis. It is coming parallel to principal axis will pass through the principal focus capital letter F after reflection. So, rule 1, a ray of light parallel to the principal axis will pass through the principal focus after reflection. Similarly, for convex mirror, a ray of light parallel to the principal axis, you can see a ray coming parallel to the principal axis, will appear to come from focus. You can see it is appearing to come from focus. So these are the first rule for concave and convex mirror. A ray of light parallel to the principal axis will always pass through the principal focus for both concave and convex mirror. This rule is just opposite to rule 1. You can see a ray in a concave mirror is passing through the principal focus capital letter F. After reflection, it goes parallel to the principal axis. Similarly, in a convex mirror, a ray directed towards principal focus, you can see it is directed towards principal focus. After reflection, it becomes parallel to principal axis. This is rule 2. Rule 3 is very simple rule. A ray passing through the center of curvature will retrace its own path. We can see it comes back in the same path after reflection in both convex and concave mirror. So in general, we can say a ray passing through the center of curvature will retrace its own path, or we can say it will take the same path after reflection. The last and fourth rule is very simple, as we have already studied in laws of reflection. For any incident ray at an angle at the pole, you can see a ray which is incident at the angle pole. The reflected ray follows the laws of reflection for both concave as well as convex mirror. So angle I is equal to R for both concave and convex mirror. So far, we have learned the basic concepts for drawing the ray diagram and also some of the rules to be followed before drawing the ray diagram for image formation. Now, let us start with image formation in a concave mirror. Now, let us learn the image formation in a concave mirror through a table. This table is going to be very interesting table. Here in this table, we are going to see the position of the object and where the image will be obtained and what is the size of the image and what is the nature of the image. When the object is positioned at infinity, you will find the image at principal focus F, and it is going to be highly diminished and the image is real and inverted. Now I am going to bring the image inside. If the object is kept beyond C, you will obtain the image between F and C. It is diminished and the image is going to be really inverted. Now, if we keep the object at C, the image will also be obtained at C, which is going to be the same size, and the nature of the image is real and inverted. Now, we are keeping the object between C and F. The image will be obtained beyond C, which is going to be enlarged image, which is real and inverted. Now, if the object is positioned at F, the image will be obtained at infinity. It is going to be enlarged and it is a big size, and it is going to be real and inverted image. Whereas in the old book, it is given as image would not be formed. But as far as the new book, it is enlarged and real and inverted. Now, if an object is at F, the image will be obtained at infinity. I have already told you it is going to be enlarged and real and inverted. Between P and F, it is going to be behind the mirror. Since it is behind the mirror, the object is virtual and erect, so it is enlarged. So, for easily to understand, at infinity and at f, you can see these are all opposite. At infinity, it is at principal focus f. At f, it is going to be infinity. Now, if you see for beyond C and between C and F, so beyond C means you will get between F and C, between C and F. At C, it is center, so it is the same size. So all these images, 5 images will be real and inverted. The only image which is going to be real and erect is between P and F, which is obtained behind the mirror. So this table is interesting to learn, and with this prior knowledge, we will go inside each ray diagram for your better understanding. Image formation in a concave mirror, the object is going to be positioned at infinity. At infinity means the rays is going to be parallel. You can see the rays are parallel. The object, it is parallel rays, and it meets at the principal focus F. So the object is going to be at infinity. This AB is the object, and you can see the image position will be at F, as we have seen in the table, and the size of the image is highly diminished or point size. As in the diagram, you can see it is a point size image. Now the image is going to be real and inverted. Real and inverted image will be obtained. As I already told, here we are going to see the position of the image beyond C. You have to draw the principal, the mirror, concave mirror. You have to draw the principal axis. You have to mark pole, principal focus F, capital letter C. Then you have to draw the object AB. When you draw the object AB, it shows in the upright position. So when the object is positioned beyond C, this is C, the object is positioned beyond C. So two rays will be coming out, 2 or 3 rays will be coming out of the position A. One ray will be parallel to the principal axis, and after reflecting, it passes through the principal focus F. Another ray which goes through the center of curvature, so it will after reflect, it will retrace its path. So the intersection part of these two rays, you can see from pole it is getting reflected. So intersection point, you will get the image formation. You should remember, always image will be formed at the intersection point. So the image A dash B dash is being formed here. The image is downward. So in the first position, you can see the object is AB. It is in the erect position, but it is in the downward position. So the object, the image is going to be downward. So the position of the image, you can see the position of the image is between F and C. You can see where is the image is positioned between F and C. And also you can see the size is going to be highly diminished image. Since it is in the downward direction, it is real and inverted. You should always remember, real and inverted are like twins. So both will be together. So real and inverted. So the image is going to be real and inverted when the object is positioned beyond C. Now we are going to see the image formation when the object is positioned at the center of curvature C. So the object is kept at the center of curvature C. Before this, I would like to reiterate that draw the concave mirror, draw the principal focus F, mark as P, then mark F, then mark center of curvature. After that, if the object is kept at C, so two rays will be emerging out from that arrow AB. It will be emerging out from AB. One ray will always be parallel to the principal axis, and it will pass through the principal focus as per the rule. The second ray from the point, this point, arrow point, it will pass through the principal focus F, and it retraces its own path. So the intersection point, uh, you can see it is at the intersection point you can obtain the image A dash B dash. So the position of the object is at C, image is also at C. The size of the image you can see A, B and A dash B dash size is same size will be obtained. Nature of the image is real and inverted. Since they are in the downward, image is in the downward direction, so it is real and inverted. If it is erect means it is virtual and erect, whereas it is downward, so it is going to be real and inverted image. Now we are going to see the image formation in a concave mirror where the object is positioned between C and F. As usual, we have to draw the concave mirror, draw the principal axis, mark the point P, mark principal focus F, mark center of curvature C. Then it is between C and F. The object is placed between C and F. A, B, the object is placed. Now you see the diagram. The object is placed between C and F. It is placed in between C and F. Two rays will be emerging from this point. Two rays will be coming out. One ray reaches the mirror and it passes to the principal focus F. Another ray passing through the principal focus will be parallel to the principal axis. The intersection point, you will obtain the image A dash B dash. Here the image is in the downward direction. So what type of image you will get? You will get the real and inverted image. So if the object is positioned at C and F, the image will be obtained beyond C. This is beyond C. So the size of the image, you can see the size of the image is enlarged. Now it is being bigger than the size of AB. Now the nature of the image, since it is in the downward direction, it is real and inverted image will be obtained for the object positioned between C and F. Now the object is positioned at F. You can see, as usual, you have to draw the concave mirror, draw the principal focus, principal axis, draw the principal axis, mark the point P, mark the point F, mark the point center of curvature C. Now the object is going to be placed exactly at F. So exactly at F, B is going to be the object. So two rays will be emerging out. One ray will be from the parallel to principal axis. Once it is parallel to principal axis, it will pass through the principal focus. Another ray, you can see it passes through the center of curvature. This is another ray which passes through the center of curvature. It will retrace its path. So the image will be obtained at infinity. So the position of the object is at F. The image position will be infinity. The size is going to be highly enlarged, and the nature, it is going to be, since it is in the downward direction, the image is going to be real and inverted image when the object is kept at F, that is principal focus F. Now let us see, the object is kept between P and F. We are keeping the object between P and F. So as usual, we will draw the concave mirror, draw the principal axis, mark P and also mark F, principal focus, then mark center of curvature. Now you see the diagram. In the diagram, you can see the object is kept in between pole and F. So the object is kept between F and P. So object AB is kept in between P and F. So a ray from A, it falls on the mirror and passes through the principal focus F. Another ray which passes through the center of curvature, it will retrace its path. But the image will not be formed in the same side. It is formed behind the mirror. So we have to extend the lining, and the intersection point will be behind the mirror, and it is at A dash. The image is going to be A dash B dash. Since the image is upright, so the what will be the image now? Whether it is going to be real and inverted? No, it is not going to be real and inverted. Since the image is upright position, it is going to be virtual and erect. So the Between P and F, you'll get behind the mirror, then it is going to be enlarged size, then the object here is different, virtual and erect image will be formed when it is between P and F. The object is kept between P and F. So far we have learned about the image formation in concave mirror. Now we shall see how the image will be formed in the convex mirror. Before drawing the ray diagram, I would like to tabulate the image formation on a convex mirror, the position of the object, position of the image, size of the image, and nature of the image. The two position it is going to be kept. One, it is going to be at infinity. If it is at infinity, the image will always be obtained at F. So if it is at F, it is going to be highly diminished or point size image. If it is if it is behind the mirror, so it is going to be virtual and erect. So between the second position is going to be between infinity and pole P. Anywhere in between infinity and pole, if you keep the object, the image is going to be obtained between P and F, and it is going to be behind the mirror. As I already said, if it is behind the mirror, it is going to be virtual and erect, so it is a diminished image. So now let us see the image formation in a convex mirror. First, the image is kept at infinity. Now, as usual, if it is kept at infinity, where is going to be the image formed? Image is going to be formed at F. Infinity, it is going to be at F. And also it is going to be behind the mirror. So, if it is behind the mirror, it is going to be at infinity means slightly diminished, and if it is behind the mirror, it is going to be virtual and erect image. So if the object is positioned at infinity, the image you will get at F. You can see it is obtained at F, and it is a point size, and also it is a virtual and erect image will be obtained. Object is positioned between infinity and pole P of the mirror. So the object is positioned, you can see the object is positioned between infinity and the pole. So image will be obtained between P and F. Since it is between P and F, it is going to be a diminished image. We already know behind the mirror means it is going to be a virtual and erect image. You should always remember, if it is a erect image, it is always going to be a virtual image if the object is kept between infinity and pole of the mirror. For examination point of view, and also to solve the problems in spherical mirrors, you need to know about the sign convention of spherical mirrors. Now let us see the sign convention of spherical mirrors, which is going to be very important for problem solving. Here I have drawn two mirrors. One is a concave mirror in the left hand side and convex mirror on the right hand side. As usual, we will be marking P principal focus. We will be marking P mirror, pole of the mirror, principal focus F, and center of curvature C. Similarly, we will be marking for the convex mirror, pole of the mirror, principal focus, and center of curvature. And here it is going to be very interesting. You can see the blue color rays and the diagram line joining the blue color are all positive, and in the red color it is going to be negative. So if the object is in the if the object or image is in the upright position, it is going to be positive. If the image or object is in the downward direction, it is going to be negative. And in a concave mirror also, if the object is towards the right, then it is going to be positive. If the ray is towards the left, it is going to be negative. So you see the mirror here in the center. You can see if the object is in the upward position, it is positive. If it is in the if it moves in the right hand side, it is going to be positive. If it is in the downward direction, it is going to be negative. And if it is in the left hand side, it is going to be negative. So in convex mirror also, you can see positive direction. If it is in the upward direction, it is going to be positive. If it is in the same direction, it is going to be positive. And if it is downward direction or it is in the opposite direction, it is going to be negative. So another important thing you should know in sign convention is focal length of concave mirror is always negative. So F is always negative in a concave mirror. Similarly, in convex mirror, focal length is going to be always positive. You have to remember this point for examination purpose. For the better understanding, I have tabulated the sign convention for both concave and convex mirror. I have taken the parameter focal length f, object distance u, image distance v, and image height v. You can see for the concave mirror, I have already told it is the focal length is going to be always negative. For the convex lens, it is going to be positive. Object distance for both convex and concave mirror, it is going to be always negative. Image distance, if the object is virtual, it negative for virtual and positive for real. For convex mirror, since it is a virtual image, it is always going to be positive. And image height, the positive for erect image, negative for inverted image. Similarly, positive for erect image and negative for inverted image, both for concave and convex lens. This table will help you out to learn the concept of sign convention for mirror. Dear students, so far we have seen about reflection of light, image formation of a concave mirror and a convex mirror, and we have also seen the sign convention for spherical mirrors. Now let us do some of the problems which might be useful for examination and also to test your understanding of concave and convex lens. Let me first go to the question hour. The first question, what is the image distance in the case of a concave mirror if the object distance is 4 centimeter? It is given that the focal length of the mirror is 2 centimeter. So by seeing this question, we can observe they are given the object distance as 4 centimeter and focal length as 2 centimeter. So object distance, it is represented as u and focal length is represented as v. F. So we have to apply the sign convention here. First we will write down what is u. U is equal to minus 4 centimeter. When you apply the sign convention for the object distance, it is opposite to the light ray, so it is going to be minus sign, so minus 4 centimeter. Similarly, they are asking what is the image distance, so we have to find out the v, we have to find out from this problem. The focal length they have given, focal length of the mirror, once again it is always going to be negative for a concave mirror. Focal length is negative for a concave mirror. So they have given 2 centimeters. So it will be f is equal to minus 2 centimeter. As we know the mirror formula, 1 by v plus 1 by u equal to 1 by f. This is the mirror formula. Now, when I substitute the values, we get 1 by v plus 1 by minus 4 equal to, we will get 1 by minus 2. So 1 by v, when you substitute 1 by minus 2 minus 1 by 4, this I can once again I can calculate, take LCM 4. This becomes here I can rearrange this before putting LCM. I can write minus 1 by 2. Here minus and minus will become plus. So plus 1 by 4. So if I take LCM for this 4, 2 into 2, 4, minus 2 will come. Here plus 1 will come. So here the answer will be minus 1 by 4. This is 1 by v. Reciprocating 1 by v, I will get v is equal to minus 4 centimeter. So image distance will be minus 4 centimeter. This is how you have to draw, apply the sign convention and solve the problem. Now let us see a case-based question, the dentist mirror. Generally, case-based questions comes as a 4 mark for 10th standard. A dentist uses a concave mirror to examine the patient teeth. When the mirror is held very close to the tooth, it shows an enlarged and upright image. However, when the mirror is moved farther away, the image becomes inverted and smaller. So based on this paragraph, they are given 4 questions. The first question they are asking, what type of image, whether it is going to be a real image or virtual image, is formed when the mirror is close to the tooth. The second question, which rule of image formation explains this behavior? And the third question, why does the image becomes inverted when the mirror is moved farther away from the tooth? The last question, which position of the image object corresponds to the formation of a virtual image? So from the paragraph, we have 4 questions. Now let us see one by one. The first question is, what type of image, real or inverted, is formed when the mirror is close to the tooth? Here the answer will be a virtual and erect image is formed because it is in between P and F. So since the objective is very close to the mirror, the image will be virtual, and it is, when it is virtual, it is always going to be a erect image. Then second question, which rule of image formation explains this behavior? The rule 1 and rule 2 explains this behavior. A ray parallel to the principal axis passes through the focus after reflection. That is the first rule. The second rule, and a ray passing through the focus reflects parallel to the principal axis. So here both first and rule applies for this behavior. The third question, why does the image become inverted when the mirror is moved away or farther away from the tooth? So here answer will be because the object shifts beyond the focal point F and causing rays to meet in front of the mirror and form. Here the image will be real and you will get the inverted image. The last question, which position of the object corresponds to the formation of a virtual image? Here it will, since the position will be between principal focus and the pole of the mirror, so then only we will get a virtual and erect image. So from this we can find out the answer from a paragraph, applying your knowledge of whatever you have learned in a case-based question. Such kind of questions may be appearing in your board examination. Now I request you students to draw a ray diagram for the object kept in between P and F in a concave mirror. And you should also find out where will be the image formed and what will be the size and the nature of the image. You try to solve this problem by yourself and find out the answer, and we will see the answer in the next session. Thank you, students, for patiently listening and for listening to the images formation of a plane mirror, concave mirror, and convex mirror. And we have seen sign convention, and also we have solved some of the problems. If you want any queries, you contact us, and also you can follow the YouTube, and I have given the contact number for the reference. And we will see the second part of the light image formation for a convex and concave lenses. So this part 2 will be the image formation for convex and concave lenses. Thank you, students, once again, and also do the problems and solve and work out whatever we have learned. Thank you so much.